Okay, so today we're looking at integration by substitution. Our learning intention is to gain the knowledge in using a substitution value or expression to make the integration easier. So we'll be successful if we can find some suitable value expressions to substitute and integrate a variety of equations. Now, sometimes they'll give you what to use to substitute, and sometimes you will need to just kind of try to apply something. Okay. So here we want to integrate 4x minus 2 to the power of 5 dx. Now we could use the reverse chain rule as we have. So if we let this inside bit be f of x, then the derivative of that is 4. Yeah. So I'm missing a 4 out of here, so I need to have 4 on the quarter on the outside. We're going to raise the power, and divide by that power. The function stays the same. So raise the power plus c. So we get the solution of being 1 over 24 4x minus 2 to the power of 6 plus that constant of variance. Okay. The alternative is to use the u substitution. Okay. And what that means is that I can let u be the term that happens first. So at the moment, if I was to do something, I would have to plug this in first and then raise it to the power. So I'm going to let u be 4x minus 2. I'm then going to differentiate that with respect to x, so du dx. Okay, and so what happens is, what we've done is we've substituted and that is dx, but we don't like dx, we can't really differentiate that in respect to x, but using this we have dx is equal to du over 4 by just cross multiplying. So we actually get u to the power of 5 du, which we like to integrate that, which we're able to do that. So that's going to be 1 over 6 u to the power of 6 plus c. Now, we didn't start with u, so we're actually going to replace that. Oh, sorry. I did forget something. This should be, dx is actually du over 4. Okay, and I can take that outside, giving me this, which is much better. Okay, so I get a quarter. I'm going to integrate u to the power of 5. Okay, fixing this up, I get 1 over 24 u to the power of 6 plus c, but we didn't really start with u, so we're going to sub u back in. I'm going to replace it. And we get the same solution. Okay. Do some more examples. Alright. Here we want to integrate this fraction. So usually in this case I want to, general rule of thumb is whatever's the denominator, we're going to use the denominator as our substitution. So let u be x squared plus 3x minus 1. I differentiate that. Gives me 2x plus 3. So dx is technically du over 2x plus 3. Okay, so that's what I do first. So what it means is that the integral becomes 2x plus 3 over u, because this whole thing I've changed to u. And dx becomes du on 2x plus 3. Okay, well this cancels out this, leaving me 1 over u du. Okay, to differentiate 1 over u, I get the natural log of absolute u plus the constant. But I didn't start with u, so I'm going to sub u back in, which is x squared plus 3x minus 1 plus your constant. And there's your solution. Okay. If we want to find the integral of x root 5 minus x dx, so at this point I'm just going to let the 5 minus x equal u. Okay, so let u be 5 minus x, du over dx equals -1, so dx equals negative du. So the integral becomes x root u du, and some negative. Okay, and that's okay, but the problem is now I've got an x here, and that's what I don't want. But we know that u is 5 minus x. Okay, so therefore x must be 5 minus u. Okay, so what I will do, five minus u, and I'm just going to put that into fractional powers. Okay, replacing that x with 5 minus u. Well, now I can just expand this, so I get 5u to the power of a half minus, multiplying that, I get u to the power of 3 on 2, 1 plus a half. And now I can integrate that. So adding 1 to that becomes 3 on 2. Dividing 5 by 3 on 2, I get 10 on 3 u to the power of 3 on 2. Raising that by 1, I get 5 on 2. And dividing by that by 1, I get 2 on 5. And then I get that constant. Okay, clean this all out. Oh, that becomes a plus. So I get negative 10 on 3 u to the power u cubed plus 2 on 5 square root u to the power of 5 plus c. Now remembering to substitute. U back out. Okay, so we get negative 10 u is 5 minus x to the power of 3. And tidying it up. Okay. Alright. So here's another example. If we have the gradient of a curve, and it's given by this derivative, and the curve passes through to -1, we want to find the equation of that curve. Okay, so what we've got to do, we've got to integrate. Okay, we don't like this because it's a bit messy, so what we're going to do is we're going to substitute u, so let u be x squared minus 1. So du on dx equals 2x, so dx equals du on 2x. Okay. So that means we're really working on the integral of x over u squared du on 2x. The good thing is that this x cancels that x, giving me with a half 1 on u squared du. That can be written as a half u to the power of -2 du. Raising the power and divide by the coefficient, I get -1 u to the power of -1 plus c, which can be written as substituting this u back in, I get -1 over 2 to the power multiplied by x squared minus 1 plus c. Okay, so we still haven't finished. We want to find the equation. So that means when x equals 2, y equals -1. Remember that this is what y is. Now x is 2, so 2 squared minus 1. So 4 minus 1 is 3 times 2 is 6. So -1 plus 1/6, we get -5/6. So the equation is f of x or y equals -1 over 2x squared minus 1 plus your constant, which is -5/6, and that's your final answer. Okay, that's it. Good luck.